Hello, I'm Kelsey Miners, a graduate student in physics at Washington University in St. Louis. Have you ever wondered how a doctor looks inside of your body? You may have heard of various medical imaging techniques such as PET scans, CT scans, ECG, echocardiograms, and MRI, such as this one behind me, which is intended for small animals. But what are each of these techniques? How do they work? What information do they give? And how do they relate to physics? Dr. James Miller, Emeritus Professor of Physics, Medicine, and Biomedical Engineering at Washington University in St. Louis, will cover these topics and more on Saturday, February 16th at 10 a.m. in Crow Hall, room 201 on the Danforth campus. This is a free lecture intended for a general audience with little to no background in physics or medicine. The lecture will be 40 minutes long with plenty of time for questions immediately following. Hope to see you there.
Hello. My name is Jim Miller. We will be talking about physics and its role in diagnostic medicine. I have spent most of my professional career at the interface between physics, medicine, and biomedical engineering. We'll be taking a look at the physics that underpins the electrocardiogram, computed tomography, positron emission tomography, magnetic resonance imaging, and echocardiograms. Our goal is to learn a little about how physics plays a role in these devices and how they function, as well as the kind of information that these diagnostic tools provide. Let's take just one example, positron emission tomography, or PET. Washington University in St. Louis played a really significant role in the development of PET. Positron emission tomography is based on matter-antimatter annihilation. Does that sound a bit like science fiction? Perhaps this brings to mind the matter-antimatter annihilation that took place in the Starship Enterprise's warp drive engines under regulation of dilithium crystals. Well, dilithium does not play a role in PET, but matter-antimatter annihilation certainly does. The antimatter, in this case, is a positron, a positively charged electron, that is emitted from an agent consisting of a modified form of the simple sugar, glucose. That agent, known as fluorodeoxyglucose, or FDG for short, is injected into the patient prior to the start of the exam. The emitted positron collides with a nearby electron, leading to their mutual annihilation and to the generation of two oppositely directed gamma rays. The scanner makes use of a ring of detectors that identify the path followed by those two oppositely directed gamma rays. The injected positron-emitting fluorodeoxyglucose might reveal, for example, enhanced glucose metabolism in cancerous tumors or decreased glucose uptake in a brain. The benefits of PET and other diagnostic procedures that will be discussed are often quite obvious. Potential risks and limitations require very careful attention, and physics plays a valuable role in those determinations. Our discussions will include the role of physics not only in PET, but also in computed tomography, magnetic resonance imaging, echocardiography, and the electrocardiogram. We plan the talk to be about 45 minutes in length. It will be followed by a very extended question and answer period for those who care to stay on a bit. I'm looking forward to this, and I hope to see you there. Bye for now.